All right, good morning, physics class. This is Mr. Sala. Today and the next few days, we're going to focus on universal gravitation. This is the reading that you want to use as you make your way through the worksheet for the multiple choice and the true false questions. What I did is I just copy and pasted the majority of the information from 3 lessons that you can also easily access from the physics classroom. So you can see that I clicked on the link, and if you are more comfortable going through the actual website, feel free to do that. But again, I just copy and pasted the majority of the information. One good thing about the website, though, is you make your way through the 3 different lessons that I want you to focus on, is that they do have some interactives and they do have some animations and some sample problems that you choose to gain some more knowledge. You can click those and they'll walk you through how to solve those. So that is the information and where you find it. I'll have the Google Doc here, and you can also just click on either of the 3 lessons and it'll take you, or I think the middle one, maybe the top 2 work, but they're all right there together. So that is the information there. The worksheet, again, on pages 1 and 2, has some multiple choice and some kind of A-B options to answer some of the questions along with some true false. Then you have a problem set here that I'll explain in a minute, a problem set here, some more true false, and then you have your third problem set here. For each of the problem sets, I've asked you to include the note sheet, have the working note sheet where the problems are worked out in detail. All right, so for the first group here, you can see I've labeled them 12A, B, C, D, E, F, and G. And you're solving for F from the equation, the universal gravitation equation. So we'll go ahead and do problem 1 here, where you have 2 masses that are each 60 kilogram, and the distance between them is 1. And this column here is showing you the significance of these mass numbers. So this would be like 2 typical students in a physics class. So 2 students, which I think if I'm doing it right, they would each weigh approximately about 130 pounds, and they were separated by about 3 points, or 3 feet 3 inches. All right, so we'll use that data and we'll go ahead and solve that problem. This would be problem 12A. So again, the universal law of gravitation problem is F equals G times the mass of the first object, the mass of the second object, and then it's the distance squared between the 2 objects. I will make a note that in the equation you saw in your notes, it's using R, but in physics classroom they just use the variable D. The reason why it's used R is because you're looking at the radius, the center of one object to the center of the other. All right, so to solve this first problem, and this would be, again, I'll put over here, this is 12A. So again, you're looking for F. G, you know, is that constant. And again, after you start doing these problems, you're just going to kind of know that constant. M1 is 60 kilograms. M2 is 60 kilograms. And your R is 1 meter. And now we just plug them in. So you had 6.67 times 10 to the minus 11. And then you have 60, 60, and then clearly the beauty of this problem is you've got 1 squared in the denominator. So really you only need to use your calculator to go ahead and solve for the numerator. So we're solving for F, and we ultimately know our unit is going to be in newtons, right? So let me go ahead and just plug that into the calculator, and then we'll solve for that. And it looks like the answer will be 2.4 times 10 to the negative 7th. Right? So that is 12a. Again, just be careful as you're plugging in your numbers into your calculator. So again, coming out of scientific notation, so if you're really looking for the gravitational attraction between you and the student sitting next to you, I guess really what we're saying is you would have 0 point, and then it looks like we'd need, what, about 6, 1, 2, 3, 4, 5, 6, 2, 4 newtons. Right. So just remember, if you ever feel a little lonely, you are still technically attracted to anybody sitting next to you through the laws of universal gravitation. All right, so that is 12a. Now we're going to look at 13a. And what you're being asked to do in this chart, and obviously we're going to do A, and then you've got to do the calculations for the other 4, is you're being asked to find the local gravity. You're looking in the equation for this now is going to be G equals G M divided by that distance squared. Right? So really what we're solving for in 13a is proof that our local gravity on Earth is what we've previously stated it was. All right, so you use your gravitational constant, 6.67 times 10 to the minus 11, and I can already hear you getting this into your head. Since we're talking about the local gravity here on Earth, we need the mass of Earth. So that's 5.98 times 10 to the 24th. And then we're going to divide that by the radius of Earth. So really you're taking the distance from the center of the Earth to the surface. And that distance happens to be 6.37 times 10 to the 6th. What's that? Oh, and yes, I'm sorry, and that is squared. Thank you. And again, thank you for pointing that out, because that's going to be one of the more common mistakes among students is they forget to square, which I just about did. So again, G is what you're looking for. You know the big G is the constant, the mass, and then you're looking for the radius squared, which was given. So now if you go ahead and solve it, you are, since we're looking for G, and that's going to be the gravity, which is an acceleration, meters per second squared, and the math comes out to be 9.83, which again, for our purposes, I've just go ahead and asked you guys to use 9.8. Right, so that is 13A. All right, so we're good to go there. So for the first chart with all of 12, you're using Newton's law of universal gravitation to solve for F. based on the data you're given. In 13, you're using this equation and you're finding the gravity for those particular situations. So the second part, which if you look at 13b, it's now telling you you'd be 60 miles above Earth. So you can see that the radius has gone a little bit up. So you can solve that. The last thing I want to point out, and go ahead and start digesting and solving the problems, is Newton's law of universal gravitation again. Here it is. M1, M2, all over R2. In some of the problems, you're going to be asked to solve for different things. So hypothetically, let's say you had a problem where you had to solve for the mass of one of the objects. Right? So you're going to have to rework this equation. The first thing I do is I get whatever's in that denominator out. So you just cross multiply. So really then you're looking at F equals, or F here, and you'd have the radius squared. You've cross multiplied. Then that leaves you here, and you need to isolate for one of the masses, so you'd have to divide through. So then your G and your other mass would be in the denominator. So that's the equation you would use to solve if you were not given one of the masses but was given the force. And again, just think about it algebraically of how you would isolate for what you're being asked for in the problem. Again, the big G is a constant, so you're never going to be asked for that. The F is straightforward. I just showed you the M. Really the only other way would be if you have to solve, say, for the radius. So again, what would you do there? You would cross multiply, so you have F R squared equals G M1 M2. Now you have to divide through by F. So now you have R squared equals G M1 M2 all over F. And the last step you have to do, since you want to get rid of the square, is ultimately you have R equals the square root of G M1 M2 all over F. All right, so I have posted, I'll post the document where you find the information to answer the multiple choice and the true false. They also have the link to the physics classroom if you want to work through the classroom website there. Then I have posted the worksheet, and you need to create a worksheet, a separate worksheet showing me how you solved each of the problems for 12, 13, and the 7 problems on page 3. This assignment is for Friday, Monday, and Tuesday. I hope this was helpful, and have a good weekend. Email me if you have any questions.